Momentum is a physical property of moving bodies. It equals the product of mass times velocity and it means that it's a vector quantity. So P equals mv. If the mass is measured in kilograms and the velocity is measured in meters per second, the unit of momentum will be kg meters per second, or as an equivalent, as we'll learn later, it's Newton second. For example, here a small trolley of mass 5 kg is traveling to the right by 10 meters per second. So the momentum equals 5 times 10 equals 50 kg meters per second. What about the total momentum of more than one body in a system? For example, here we have two trolleys. The first one is 2 kg traveling by 4 meters per second to the right. The second one is 5 kg traveling by 6 meters to the right. So the momentum of the first one is equal to 2 times 4 equals 8. The momentum of the second one is equal to 5 times 6 equals 30. So the total momentum equals P1 plus P2. Both of them are traveling in the same direction, so it will be 8 plus 30, so it's equal to 38 kg meters per second. Here we have the same two bodies, but this time one of them is traveling to the right and the other one is traveling to the left. So if I want to calculate the total momentum, it will be again P1 plus P2 equals, if we consider the right to be positive, so the momentum remains positive, it will be 8 plus, if we talk left now as negative, it will be minus 30. So the answer will be minus 22 kg meters per second, and it means that the momentum or the total momentum of the system is 22 kg meters per second towards the left. What about the change in momentum? This trolley, 3 kg, traveling by 8 meters per second towards a wall, it hits the wall and bounces by 6 meters per second. So the initial momentum here is 3 times 8, which is 24 kg meters per second. The final momentum here is 3 times 6, which is 18. So the change in momentum equals to the final minus the initial. The final is 18, the initial is 24, but as we agreed before, it's a vector quantity, and as you see here, they are not traveling in the same direction. So if we talk the left as positive, the right will be negative. This means that the answer is 18 plus 24. So the answer is 42 kg meters per second. And if the answer is positive, this means that the overall change is acting towards the left, since we consider the left to be positive and the right to be negative. What about in a system where bodies get collided with each other? The main rule here is the conservation of moment. The total momentum before the collision is equal to the total momentum after collision, and this happens within any isolated system, any system where there is no external forces acting. So if I want to calculate the total momentum for the first body and the second body before the collision, it's equal to the total momentum after the collision, which is the mass of the first times the velocity of the first plus the mass of the second times the velocity of the second, and we need to consider the directions here for velocities. For example, here 2 kg traveling to the right by 2 meters per second collides with unknown mass m traveling to the left by 4 meters per second. It seems after the collision that both of the trolleys are traveling to the left. So here we can consider the left to be positive and the right to be negative. So if I want to calculate the total momentum before the collision, m1u1 plus m2u2 equals m1v1 plus m2v2. The first mass is 2 times the first velocity is 5 to the right, and here we consider the right negative, so it's minus 5. Plus m2 is unknown, so we'll keep it as m times u2, which is 4 to the left, and we consider the left positive, so it's times 4, equals m1v1, so again it's 2 times 3, which is to the left, plus the unknown mass times 1.5, and then we will do the math. Another example here, 5 kg traveling to the right by 6 meters per second hits another 5 kg traveling to the right by 2 meters per second, and both of them gets stuck and move together as one. So according to our rule, m1u1 plus m2u2 equals m1v1 plus m2v2. But as we see here, the two bodies stuck together, which means that they are traveling by the same velocity in the same direction, so it's the same v. So we can take the v here as common, so it's m1 plus m2 times v. And here m1u1, so we have 5 times 6 plus 5 times 2 equals m1 plus m2. So it's 30 plus 10 equals 5 plus 5 times v. So v is equal to 40 divided by 10 equals to 4 meters per second, and here all traveling to the right. Figure 2.1 shows two fireground bumper cars, stationary empty car 50 kg in front of a moving car that has passengers traveling to the left by 2.5 meters per second. After the collision, the empty car moves forward in the same direction at a speed of 4 meters per second. So if we call this one as m1 and this is m2, so this would be v2 since this is after the collision, and this is the m1 here and this is the m2 there. For the car with passengers, determine the momentum when it's traveling at 2.5 meters per second. So the momentum of the first car is m1u1 equals 200 times 2.5, so it's equal to 500 kg meters per second. The speed and the direction of its motion immediately after collision. Again, m1u1 plus m2u2 equals m1v1 plus m2v2. We got the first momentum already, 500, plus the second car was stationary. The first mass is 200. The speed after collision is unknown, plus the second mass is 50, and it traveled to the left by 4 meters per second. Doing the math, so the speed is 1.5 meters per second, and the direction is to the left since it has the same sign that we considered from the beginning to be positive, which is to the left. A bullet of mass 0.1 kg travels horizontally at a speed of 600 meters per second. It strikes a stationary wooden block of mass 1.9 kg resting on a frictionless horizontal surface. The bullet stays in the block. What is the speed of the bullet on the block immediately after the impact? So it's m1u1 plus m2u2 equals m1 plus m2 times v, since the two bodies stuck together. So the bullet is 0.1 traveling by a speed of 600 plus the block was stationary equals the total mass now is 0.1 plus 1.9 times v. So the answer is